Welcome back, everyone. So the next session is going to be a workshop. How to use Frost. Includes demo, here it says. So we have Corrado and Deirdre from the Zcash Foundation. So here we go. Have fun.
Hi, I'm Deirdre, and with me is Corrado. We do cryptography at the Zcash Foundation. We're talking about Frost, which is flexible, round, optimized Schnorr threshold signatures. What is a threshold signature? It's a signature scheme where you have to have a minimum of T signers out of a possible N set of participants to produce one signature. This is very useful if you want to have no single party to have full control over signing authority, and threshold is nicer for certain situations than something like multisig because it produces a single signature that is the same size and computation verification cost as a single party signature, for example, Schnorr. Schnorr signatures are used in multiple places in Zcash and many other places in cryptographic protocols in general. When you set up your participants for doing Frost threshold signing, you have some sort of key that is split amongst n possible parties with a configuration parameter T, the threshold. You need T or more to collaborate together, and for Frost that's a 2-round protocol of passing messages back and forth and doing cryptographic operations to end up with a signature at the very end. And you can create these key shares in a distributed manner such that no one party ever has the full secret key, the full signing key, at any one time. This gives us very nice security properties, but it also, with threshold, means that when you look at the signature you produce, you can't tell exactly which parties produced that signature, only that at least T of them were involved in producing the signature. And that gives us very nice privacy properties as well, which we care about for Zcash. Some other things that we in our software package implement to help you use Frost include if you have a certain number of the existing participants work together, you can recover a lost share, which is extremely helpful if you're sharding control over, say, a Zcash spending key, a spend authorization key. And one of your parties lost their share. They lost their wallet, their hardware wallet, or something like that. If you have at least T parties, you can help reconstruct that share and make the participation whole. You can issue new shares if you want to bring someone into your pool of possible signing participants, but without changing the threshold T. And then you can refresh all your shares if you just want to it's been a long time since we created these shares. We just want to refresh them all. We have support for that too. Since last year, we've done a lot of work. We almost had our official RFC specification locked for forevermore. And then as we were working on applying Frost to Zcash situation, we realized that we weren't including the group public key when computing a piece of computation signing called the binding factor. This isn't a problem for security so much, but when we are using it for Zcash, that group public key will change because we want these nice privacy properties of re-randomization. But we weren't including that updated group public key in that computation. Other parties, including some work that was published last year at Crypto, assumed that we were already including that group public key in their security proofs. This was a quick and easy change to update in our spec, but it meant that we had to take 2 steps back in the standardization process. So we are still waiting to finish the last few hurdles in the standardization race to get that Crypto Forum Research Group spec finalized. We've updated our code to include this recent change, and we've had multiple new implementations by other independent parties of the latest changes to the Frost specification. And it seems to be going extremely well. No one comes to us and says, hey, I'm trying to implement your spec, I have questions, or this was very difficult, or anything like that. They come to us with an already fully compliant and generally good-looking implementation and say, hey, I have this. It's a good spec, thank you. And that makes us feel really good and confident that we have a good specification product there. As I mentioned, there were a couple more analysis of Frost in different security proof models at crypto last year. And that gives us even more confidence in the different security properties about unforgeability and things like that, based on different cryptographic assumptions of what makes something secure. And it's very reassuring that other parties are taking Frost seriously enough to, like, you know, really bang on all the edges and say it's a good one. And then, as I mentioned, we have a re-randomization adaptation of Frost to the Zcash setting. When we produce the spend authorization signature for sapling and for orchard transactions, we have the ability to re-randomize that signature so that anytime you look at those signatures on chain, you cannot verify all of the signatures with the same verification key, which would be a privacy leak. So to specify exactly how you re-randomize Frost, we have drafted ZIP 312 that is continuing to work with us as Corrado especially implements the re-randomization, and we work with Chelsea Como, co-creator of Frost, with the updated security proof of the unforgeability properties of re-randomized Frost. So we've been moving back and forth on these for a while. We have code, we have a draft security proof for re-randomization, and we have some demos to show you about how to use this variant of Frost for Zcash. And part of that code, part of that demo is our updated crates that have been released. They're on crates.io. They include all the cipher suites in the RFC document and the red Jub and red Palace versions that are needed for Zcash. And we've just completed our readout of our audit of those crates, and then we all immediately got on a plane to Barcelona. So there'll be a readout of that security audit of the software and some of our dependencies that we use after we get back from Zcon. We think it went very well. We're pleased. And then, of course, we've done a lot of integration work and sample code about how you take all these, fundamental crates and Rust libraries and build it into application software. So I think Corrado is going to show you some of that.
Thank you. Right, so I start talking about, some possible use case for Frost, just to make people understand how can I use it, how can it be useful. So the first scenario that I had in mind was something like a shared custody service, because right now either people who use Zcash, they either keep their own keys, which is good in a sense, but it's bad because if they lost their phone, if they lose their seed phrase, they lose their Zcash, they lose their money. Or they can keep their key on an exchange, on a service or whatever, but that's also bad because if they get hacked or they lose your keys, you also lose your money. So with something like this, you can share the custody of your key. So for example, you can generate your key, use 2 out of 3 threshold, split into 3 shares, keep one share in your phone, keep one share in your cloud, and keep one share with this shared custody service, which I name it like this. So if you set this up and you want to send Zcash to someone, then you need to, your phone communicates with the service to do Frost and create the signature, and that works. If you lose your phone, you can use your cloud share to restore your share in the phone and regenerate the cloud share. Or if the service you're using goes bankrupt, you can, switch to another service or just, recover your key. So I think that's a useful scenario. Another possible scenario, which I also think will be popular, is if you have like an organization which needs to share some funds, Zcash funds. This is an example of 3 out of 5, but it could be 2 out of 6 or whatever. So you could do distributed key generation, so that the key doesn't actually exist anywhere, you just have the shares of the key. And each person uses their smartphone to run Frost. I need to send 3 Zcash to this organization. So 3 people get together, sign using Frost, and authorize that transaction. If anyone lose their phone or lost his phone, they can recover their share with the help of the other participants. Cool. So how Frost works? I'll just very high-level explanation. I won't enter into details. So the first thing you have to do is actually generate your key, and there are 2 ways to do that. The first one is trusted dealer key generation, which basically you have a coordinator who will generate the key and split it into shares and send one secret share to each participant. And the participant will receive this and call a try into function, which will validate the share and turn into a key package. And then another possibility is distributed key generation, where the key never exists in memory, right? You create it already splitted. So here I'm showing one participant, could be anyone, and here are the other participants. So in the first part, you create a package that you need to send to all other participants, and you also receive the package from the other participants. You get all these packages and call the part 2 of the DKG. Again, we also generate another package, but now it's a specific package for each other participant, and we also receive a package from them. And then you call the part 3 function, which will finally generate a key package. So that's key generation. So you want to sign with Frost. You have this coordinator and the participant. Coordinator and participants are just roles. All participants could be coordinators if they want. It's just a way of viewing the protocol. So this coordinator will choose a message that it wants to sign, and the participants will run this round 1 commit function to generate commitments. We will send them to the coordinator, which will create the signing package, which contains the message and the commitments, and send them back to each participant. So each participant will receive the signing package, the nonces that they committed to, and the key package that was generated before, to run the sign function, which will finally create the signature share, which all of them send it back to the coordinator, which will aggregate the shares to produce the final signature. So that's the main part of Frost. That's cool, but how do you use it with Zcash? So there's one small problem is that Zcash uses re-randomized signatures. And the reason for that is that if I will use the same key, the same public key in all transactions, then anyone can see, these 3 transactions use the same public key, therefore they are from the same person, right? You break privacy. So each signature in Zcash is randomized, so you need randomized Frost. But luckily, that's not difficult. You just need some small adaptation on how, you need a way to randomize your share, so that's possible to do, and then run regular Frost. This is being specified on a zip. It's already up, but it needs to be reviewed, simplified a little bit before we officially submit it. And that's happening soon. And the result is very similar to Frost. The only difference is that here the coordinator needs to pick a randomizer, which is a random number basically, and send them to the participants, and they will randomize their shares and send the signature share back to the coordinator, which you also use a randomizer in this aggregate function. That's the only difference. You just need to send one additional value to the signers. Cool, but how exactly, where do you use Frost? So Zcash is a bit complex protocol. So here I'm showing the key. I call these key trees of Zcash. This is the sapling and this is the orchard. So usually, all of these keys are derived from a single spending key, which is also derived from your seed phrase, right? So we have a seed phrase, turns into a spending key, which derives all of these keys. And the key where we actually need Frost is the authorizing spending key, ASK, which is here, right? Here in sapling, here in orchard. So you can do that. You just split the ASK into shares. There's one tricky part, which is usually you derive ASK from the spending key, right? This arrow here. which will make you think that you wouldn't be able to use DKG, for example, because with DKG you can choose your key. But that's not a problem because this error is like not enforced by the protocol, right? There's nothing stopping you from generating your own ASK instead of deriving it. So that works. And you can even, it could be easily useful, even if you're using trusted dealer, where this wouldn't be needed. Maybe it's actually useful to not derive it from a seed phrase, because the whole point of Frost is not to have a single seed phrase. So that's probably something that you want to do regardless of the key generation process. This will require some new APIs with the libraries, for example, to generate a full viewing key, not from a single spanning key, but from a spanning key and AK. AK is the group public key from Frost. So yeah, you need a small API changes to generate this, but it's not something complicated. Cool. So you're using Frost, but of course you need to worry about what if I lose my phone, what do you need to store, what I need to back up. The things that you need when you use Frost, you need the identifier, which is basically a number, and this number can be derived from a string, so it will probably easier to just use a username, email, or something. You need the signing share, which is actually the share of the secret, a verifying key, which is a group key, which is the AK that I showed you, and the other participants, identifiers, and verifying shares. And the remaining of the Zcash material, the key tree I showed you. In this case, Orchard is a bit easier because if you have a full viewing key, you can derive the rest, right? So you just need your Frost share and the full viewing key, and you're good. Sapling is a bit more complicated because you need this proof authorizing key, right? So it will be a bit trickier to hand sapling. Or should we even back up at all? Should we just rely on recovery share feature of Frost? That's something that we need to know, wallet developers, and we need to decide and work out. Another challenge is communication, right? Frost, you need to send packages between participants. And how do you do that? Wallets don't usually communicate with each other. So you need a communication channel, and Frost requires that this channel must be encrypted and authenticated. So in a scenario like I showed you of the shared custody service, you could use TLS, right, from the phone to the server. That's kind of easy. But in a scenario B, where there's a bunch of persons, there's no single server, then that will be trickier. Because you need to manage contacts, you need like a communication public key, not a Zcash public key, like a public key for doing this communication channel, authenticating this communication channel. So people need to, I don't know, scan QR codes. This is another thing that we need to figure out. We are starting to develop a library, which we call a cons, probably, to help with this, but it doesn't entirely solve it. You need the infrastructure for a wallet to communicate with each other. Usually people are behind firewalls, behind nets, so it's difficult to just open a TCP connection with another wallet. So yeah, this will need some figuring out how to do. There are some workarounds if people, I need to use Frost now. Maybe you can just copy and paste base64 blobs via Signal. That works, not ideal, but that works. You also need a broadcast channel, and this is something like it's a primitive from distributed computing. It's not just getting your message and sending to everyone. It's actually, you need to take steps to ensure that everyone gets the same message, and this is needed in key generation for Frost. Luckily, there's a protocol which is kind of simple from Goldwasser and Lindell that we're looking to implement in your library. But yeah, you need to be aware of this, that you actually need to use this when it's required. So that's Frost with Zcash, but how you actually use with wallets. So one idea that we had is that using Frost is very similar to using offline wallet. So some wallets, like Y wallet, support offline signing, and this means that you have an online wallet, which is view only. You only have the view key from the wallet. So you can see the transactions, but you can actually spend your money. But you can create a transaction plan, right? So I need to send this amount of Zcash to this to this address. You create a transaction plan, and then you send, you put in a USB key or something to an offline wallet, which actually has your spending key. And then you sign a transaction, and get this signed transaction back to the online wallet and broadcast it. So Frost will be very similar. We expect that you have like a coordinator wallet, which has the viewing key, but can't actually spend Zcash, but you can create a transaction plan, which is sent to the share wallets, the participant wallets, and they just hold a share of the spending key, the Frost share. So they will sign with their share to create a signature share, and the coordinator wallet will aggregate them. So it's similar, so it's probably a good idea for wallets. If they want to support Frost, they probably will need to support something like offline signing. Making both is probably makes sense. So here's some guidelines. You don't need to actually have a coordinator wallet, a share wallet. You can do the same, just a view of roles, right? But this will require a new mode for the wallet, not a view only, not a full wallet, but a Frost mode for the wallet. It's also important to be aware that transparent keys are not supported with Frost because Frost only works for Schnorr signatures, and transparent use ECDSA, which is not compatible. Unless the cache integrates Taproot, but I don't know if that's going to happen. But who cares about transparent transaction, right? We want to show the transactions. Like I mentioned, sapling could be more cumbersome, so maybe it makes sense to just support Orchard with Frost. I don't know. And another challenge was use identifier. Like I mentioned, you could use a username, an email address, something that we also need to decide. So here are like some user stories that I think will be needed to supported by wallets to use Frost. You know, I think it's good to view like this, like I'm a user, what I need to do with my wallet to use Frost. So the first story would be setting up comms. So that's probably the hardest part. Like I mentioned, you need to communicate with people, so you need their public keys. So you need to generate a public key. The other participants need to read their public key and manage a list of contacts. But having that, the rest is easier. So you need an option in your wallet to create a new DKG wallet. So you go to the wallet or create a new DKG wallet, and other persons do the same. They choose their contacts and run the protocol, and that's it. You will also need the option to create or join a trusted dealer wallet. So the creator will create the share, select a bunch of contacts and create the shares, and the other participants will join and receive those shares. Then actually send the Zcash, which you go to the wallet, selecting an address, select an amount, click send, but you won't actually send. You will actually send a request to the other participants to authorize a transaction, generate signature shares, send back to you, and finally broadcast the transaction. And some additional stories like backup, repairing someone's share, refreshing everyone's share, or just, I don't want to use Frost anymore, I want to convert to a regular share. As long as you have a threshold of persons agreeing, you can do that. Cool. So what is next? What is done now? We have, our libraries are completed, are fully functional, but without any communication support, so that's up for the library user to handle. We also have the re-randomized Frost, we read the SA crate, which allows you to use Frost with Zcash. And what needs to be done? We need to finish the zip, but that's happening soon. there's some small changes to do with the Zcash libraries to support, like I mentioned, but that's not probably not difficult, and we can do, and ECC can review. You will need some communication library to actually send packages between wallets, so we're going to work on that, but like I mentioned, you also need some infrastructure on top of that. And integration with the wallet itself, which hopefully the wallet developers will be interested in working on. Right, so before questions, let's do the demo. Can we switch to the notebook, please? Oops, block it. Yeah. So what I have here, I pre-created the wallet because showing the key generation would take too much time. So I run the KG. I created a group public key, and with a tool that I wrote, I derived a unified viewing key for this, which I restored in Y wallet, which supports, view-only wallets. So I have this wallet here, which only doesn't allow me to directly spend anything. And let's try posting to Zec pages, right? So if you're not familiar, just like a message board powered by Zcash. So here's the address. So let's send to this address this amount of Zec, 0.001, which is what Zec page needs. And let's put a message here. So this is a signed post from Zcon4, yay. So that looks good. Let's send it, but it will not actually send it. It will show me the transaction plan. Of course, I got an error because I think I'm not connected to Wi-Fi. Just a second. Of course, that will happen. Why is not working? Why? Let's turn off and turn on again. Didn't turn off. Sorry, I didn't have a backup plan for this specific scenario. I'm very sorry. Let me try this. Any ideas? Oh, yeah. Maybe.
Oh,
Sure, we can answer a few questions.
sure.
Worst case scenario, we can do this demo on the wallet session that's happening later. Sorry about that.
So we have a few questions. So the first one is, what is your favorite practical example of using Frost?
I do like the Zcash example where you can shard spending authority across multiple parties in a privacy-preserving way, now that we especially have the re-randomization stuff. I'm really interested in like protecting secrets and backup for things like maybe not necessarily UTF or security keys, but things like protecting your password manager and things like that in a way that your whole life isn't ruined if you forget your password or you forget your backup or like it was on one computer or something like that. And it's not the same as having multiple copies of the thing, but you have a shard of, a key on your computer, on your phone, on, your thing at home or whatever, and you can use T of N of them to authorize something. I would like to see Frost or things that derive from Frost influencing kind of security mechanisms in the broader world, and I've seen proposals along those lines.
All right, I think we have time for one more question. Are there any use cases where Frost is not practical? What would you use instead?
Well, if you have an ECDSA signature, you can't do ECDSA signatures. So classic Bitcoin signatures or classic signatures in other settings that use ECDSA, which is a very popular signing algorithm, it doesn't work for those. There are threshold signing schemes for ECDSA. They are less attractive than Frost. And ECDSA as a signature scheme, independent of these sort of threshold concerns, is a little bit less attractive than pure Schnorr anyway. And kind of we cryptography people would like to see more adoption of pure Schnorr than, continued usage of ECDSA. And this is one reason that the Bitcoin folks are trying to move to Taproot. So I wouldn't give a recommendation in that case because I don't think they're very attractive alternatives for threshold ECDSA.
All right, we're running out of time, but I think this question is good for the audience. So can we run the demo code ourselves? Is there anything we need to be careful of?
Yes, you can run the demo code. I need to write a bit of documentation of how to run it, but hopefully we'll get that done soon. I think I can show you something at least. We don't have much time, right? We don't have any time, I think.
Yes, we were kind of over time.
Sorry about that. Hopefully stick around for the wallet discussion session that will happen later. And if people want, we can try showing here.
Yes.
Sorry about that.
All right, so I think that's everything. Great to have you Frost people here. Frost. Yeah, I'll never remember what Frost means, so it's good that it has a good name. So thank you very much. And applause for Corrado and Deirdre.